Hello everyone, today we're going to be talking about defining and using series. So series is when there's the terms of a sequence and they are added together. So very similar to what we learned about last time, but now instead of those commas being there, we are adding all those terms together. And so we have a finite series, which would be, for example, 2 plus 4 plus 6 plus 8. So there's a finite number or limited number that of terms that are in the series. And then there's an infinite series where you have 2 plus 4 plus 6 plus 8 plus, and then you'll see that ... So it continues on forever in that pattern. And something that we use to write these series is summation notation. So for example, for a finite series, that same example we're looking at of 2 plus 4 plus 6 plus 8, we have the summation notation, which is this sigma notation, is another word for it, where we have I equals 1 to 4 of 2i. So the 2i is the pattern that we have here, because whenever I plug in the term, so like for instance 2 times 1 is 2, that's my first term. When I plug in 2 times 2 is 4, which is my second term, and so on. So it's kind of like what we did last time of writing the pattern of the sequence. And this I equals 1 to 4, this I equals 1 tells us where we're starting at. So here we start at 1, and then the 4 is where we're ending at. And so that's what our last term is going to be. And then for an infinite series, it looks very similar, except the only difference here is at the top we have that infinity sign. And that just represents that this series goes on forever. And so some terms that we have here is the index of summation is I. So let's write that. And the lower limit of summation is 1 for both of them. So I'll just say lower limit. And then the upper limit of summation for this one is 4, where the other one is infinity. And this sign here is called sigma. So let's look at some examples of using the summation notation. So for each of these, we're going to write each series using summation notation. So for this first one, we have 25 plus 50 plus 75 plus ... plus 250. So here I see that this one is finite because I do have that last term. And so here I'm looking for a pattern. I see that I'm going up by 25 each time. So in other words, it has a slope of 25, so I can say that this is the same thing as 25 times 1, 25 times 2, 25 times 3, and then this is the same thing as 25 times 10. So in other words, AI is equal to 25 times I, where I is equal to 1, 2, 3, ... 10. And so with this information, we can go ahead and write this in summation notation. So my pattern goes to the right, that is 25i. And then I need to put my lower limit of summation and my upper limit. Well, my lower limit is what it starts at, and it starts at 1. So that means that I is equal to 1. And then my upper limit is my last term, and so that is going to be 10. And so this is what it's written in summation notation. Okay, let's look at another one. Here I have 1/2 plus 2/3 plus 3/4 plus 4/5 plus ... So here it ends with the ... so that means this just goes on forever. So I know this is going to be an infinite series. And I noticed that for each term, the denominator of the fraction is 1 more than the numerator. So in other words, AI is just going to equal to I over I plus 1. And I see that with this first one. I have 1 over 1 plus 1. This next one is 2 over 2 plus 1, and so on, where I is equal to 1, 2, 3, 4, ... So in other words, writing this in summation notation, I have my pattern that goes to the right, so I over I plus 1. My lower limit of summation is where I'm starting. I'm starting at I is equal to 1. And since this is an infinite series, the upper limit is infinity. Okay, let's look at 2 more. So number 3, I have 5 plus 10 plus 15 plus ... plus 250. So here I see I'm adding by 5 each time. And so I can think of this first one being 5 times 1. This next one being 5 times 2. 5 times 3. And then 5 times 50. So in other words, that means that each term is going to be 5i, where I is equal to 1, 2, 3, ... 50. So writing this in summation notation, I get my pattern goes to the right, so 5i. My lower limit is what I'm starting at, which is I equals 1. My upper limit is the number of terms I have, which is 50. Okay, let's look at one more. So here I have 6 plus 36 plus 216 plus 1296 plus ... So again, I'm looking for a pattern that I'm following with each of these. And something that I notice is that these are all a power of 6. So this first one is 6 to the first power. The next one is 6 to the second power, 6 to the third power, 6 to the fourth power, and so on. So that means that each term is going to be 6 raised to the I power, where I is equal to 1, 2, 3, 4, and continues forever. And so that means writing this in summation notation, I have my pattern, which is 6 raised to the I power. I starts at 1, and since this is an infinite series, it goes to infinity.